All right, let's try number 4. So the first term of a sequence is -9, and my common difference is 2. It first wants me to write the first 4 terms of the sequence. So again, a sub 1 is -9, and my common difference is a positive 2. So D equals 2. All right, so I'm going to start writing. And just so y'all see, remember this is a sub 1, a sub 2, a sub 3, a sub 4, okay? And -9 is the first. So all I'm going to do is I'm going to add 2 to my next term. So 9, or -9 plus 2 is -7. -7 plus 2 is -5. -5 plus 2 is -3. So there are my first 4 terms. Now, I want to write a function f of n to represent this sequence. And I'm going to start with my explicit formula. So I'm going to have, again, a sub n equals a sub 1 plus n minus 1 times d. So I'm going to start. A sub n equals, my first term was -9, plus n minus 1 times my common difference, which was a positive 2. And then now I'm going to simplify. So I'm going to backwards distribute. So a sub n equals -9. 2 times n is 2n. 2 times -1 is -2. And then my last and final step is to combine like terms. So I have 2n, and -9 plus -2 is -11. All right, so here is my explicit formula that represents the sequence. Now I'm just going to go change notation, and it says f of n. So I'm going to replace a sub n with f of n. So f of n equals 2n minus 11. All right, you try the next one. Actually, this is a recursive formula. So actually, let's go through this. So given the recursive, so I'm going to have a sub 1, a sub 2, a sub 3, and it's asking me to find the first 4 terms. So I'm just going to start this. So my first term here, they're giving it is 10. Okay, then they're telling me my common difference is subtracting or -3. So 10 minus 3 is 7. 7 minus 3 is 4. And 4 minus 3 is 1. So you go and finish letter B, which you can change that, use this sequence to create an explicit formula, and then change a sub n to f of n. All right, let's look at number 5. Number 5, I'm given the function below, and I want to write a sequence out for the first 4 terms. Then state the domain and range for each. Okay, so I'm given this beautiful linear graph. This linear graph is continuous. I have connected the coordinate points. It has arrows on either side. It's going on forever. Okay, and when I'm looking at domain or range, okay, and I'm looking at a continuous graph, there is no way I would ever want to write every x value that this function is using. So as I'm looking left, this function is going forever left. So I'm using all the negative x values. Okay, as I look to the right, it's going to go forever right and down. So I'm going towards all the positive x values. So this is going to be all real numbers. I want all the negative x's. I want all the positive x's. Okay, if you're in other classes, this can also be written as negative infinity to positive infinity. Now my range is talking about my y's. All right, so I'm looking at how far down this can go to how far up this can go because my y-axis is vertical. So looking at this linear function, it's going to go down forever to all my negative y values. It's also going to go up forever to all my positive y values. So again, I want all real numbers. Or again, this can also be written as negative infinity to positive infinity. All right, so I'm going to now take this continuous function and I'm going to create a sequence based off of it. And again, remember, This a sub 1 is saying x is 1. All right, what is the y equal to? So I'm going to go to my x-axis at 1, and my y value here is -1. Then I'm going to go to when x is 2, and my y value is -2. Then I'm going to go to 3. So when x is 3, my y value is -3. And when I go to x equals 4, my y value is -4. If this is a sequence, this is discrete. I would literally have this same graph, and I would have just coordinate points here. I would not connect a sequence. So this is the difference. Continuous, discrete. My domain and range are also different. I'm not looking for every single x value in between these coordinate points. I'm only looking at this coordinate point, this, and this. So my domain is my x values or my term numbers, which is 1, 2, 3, 4. If I have a dot, dot, dot up there, I'm going to do a dot, dot, dot down here. My range is actually my terms. So this is going to be -1, -2, -3, -4, dot, dot, dot.